Hello everyone, in this problem we're going to discuss an optimization example. So suppose that group tickets to a concert are priced at $40 per ticket if $20 tickets are ordered, but cost $1 per ticket less for each extra ticket ordered, up to a maximum of 50 tickets. For example, if 22 tickets are ordered, the price is $38 per ticket. Find the number of tickets that maximizes the total cost of the tickets. Okay, so first we're going to think of easy numbers. So so we can have um, so when we have 20 tickets, each ticket will cost $40. Okay, so I'm gonna label this number of tickets, cost per ticket. Okay, so if we have 20 plus 1 tickets, we will pay 40 minus 1 per ticket. Okay, so in the same fashion, as you see, one increases by 1 each time, or multiples of 1, while the other, the cost per ticket, decreases by the same multiples of 1. Okay, so we can actually um, have 20 plus x, right? X will mean the number of uh, increases by 1, okay? While 40 will decrease by the number of these increases, okay? Because x can be, if x is equal to 5, then the number of tickets will be 25 and the cost per ticket will be 35. Okay, so we can include the same variable. One is added, the other is subtracted. So this is basically our cost function. Okay, so now we need to find the number of tickets that will maximize this cost function. Okay, so the value of x that will maximize the c, the cost. So before you do that, we're not going to use pre-calculus, we're going to use calculus, right? So we're going to take the derivative, so we have to actually use the FOIL method to make this a quadratic polynomial. So it's going to be 40 times 20 is 800, and then minus 20x plus 40x minus x squared, and that simplifies to minus x squared plus 20x plus 800. Okay, so, and this is the cost function, so we have to find the value of x here that maximizes this cost function, right? So the derivative now is going to be c prime x. We find the derivative because the derivative tells us where the slope of this quadratic curve here will be 0, because that will be the maximum value in this quadratic function. Okay, so first we will take the derivative to find the derivative function, then we're going to set it to 0 to find the respective value of x. Okay, so the derivative using the power rule will be minus 2x. 2 decreases by the power of 1, and that 2 had to be brought up as a constant multiplying the x, right? So we have negative 2x to the first power plus 20, and x is to the first power. That power multiplies the 20, so it doesn't change. The constant is the same. And the x power 1 decreases by 1, so it's x to the power of 0, which is simply 1, right? So we don't need to write the x anymore. So this simplifies to minus 2x plus 20. Okay, so now we have to set this derivative function to 0 to find the x that will yield uh, the derivative function 0, right? So it's going to be 0 is equal to minus 20x plus 20. Subtracting 20 on both sides gives us minus 2x is equal to minus 20, dividing both sides by negative 2, gives us x is equal to 10. Now keep in mind that 10 is not the answer to this problem. Why? Because don't forget that originally the cost function was expressed by the number of tickets multiplying the cost per ticket, right? So x by itself is not uh, the number of tickets, right? It's a participant in the number of tickets because the number of tickets, as we discussed before, was 20 plus x, right? So let's bring this up again. 20 plus x. So now using the value that we found, x is equal to 10, we can find the maximum. Okay, so the maximum number of tickets is going to be equal to simply 20 plus 10, okay, the value that we found. And that is equal to 30. So this is the maximum number of tickets. Sorry, not the maximum, the number of tickets that will maximum. Oh, I think I should rewrite this in order to avoid confusion. I should say number of tickets for maximum C, okay, the cost. Okay, for maximum C, that is equal to 20 plus 10, which is equal to 30. Okay, maximum number of tickets is 30. So hope you enjoyed this tutorial. Please subscribe and I'll see you in my next video.